Hi, welcome to KubeCon. My name is Jos de Winne. I'm a solutions engineer for Replicated. And in today's session, we will see how we can use troubleshoot.sh to troubleshoot a Kubernetes application. More specifically, we're also going to use regular expressions to look for certain passwords. Let's get started. Let's start with an overview of what we will go through. First, I will give you an introduction into what troubleshoot.sh is all about. Next, I'll show you an example how you can collect the logs of your Kubernetes application. We will see how we can analyze the output of those logs and check for certain messages. As a next step, we're going to use troubleshoot.sh to exec into a pod and capture certain content. In that content, we will apply regular expressions on and see if there's any matches. As a final part, we're also going to see how we can use troubleshoot.sh combined with kubectl to use our regular and familiar kubectl commands to interact with a support bundle generated by troubleshoot.sh. So what is troubleshoot.sh all about? Troubleshoot.sh comes as two kubectl plugins. There is a pre-flight plugin and there is a support bundle plugin. The pre-flight plugin is typically used before you install your application into the Kubernetes cluster. The support bundle plugin is typically used when your application is already installed and something is going wrong and you want to get a support bundle from your customer, but they of course do not provide you kubectl access to their cluster. Under the hood, both of these plugins are based on three different concepts. One is collecting information, two is the redaction of the collected information, meaning taking out things like passwords, usernames, IP addresses, and the third part is analyzing the collected information. As you can see on the right hand side here, you can already see it in action, what it will look like from a pre-flight kubectl plugin and from a support bundle kubectl plugin perspective. If you browse to troubleshoot.sh, you will get an overview of the three main concepts. One is collecting the data, and as you can see here on the left-hand side, there are different collectors available out of the box. One of the most common ones will most probably be collecting the logs of your application, which is done by the logs collector. And this is, of course, using selectors in order to select the correct pods. But as a matter of fact, anything that can run in a pod can actually be used as a collector. So you can actually do a lot more than just collect the logs. You can check database connectivities. You can check cluster status. All of that is possible. The second part of troubleshoot.sh is redaction. And as you can see, there are also out-of-the-box redactors available. By default, troubleshoot.sh will take out things like passwords, API tokens, IP addresses, and remove those from the generated support bundle. The last component is analyzing the information. So the analyzers run on top of the information that was collected. And similar to the collectors, there are several analyzers available out of the box. For example, checking the status of your Kubernetes resources like deployments or stateful sets in there, but also analyzers that, for example, run on very common external resources like Postgres, MySQL. Those analyzers can be used out of the box. And as you might guess, there is also an analyzer that makes use of regular expressions, so you can start applying regular expressions on top of the collected log output of your pods. So what does it take to get these plugins installed and be able to make use of them? First of all, I already have an application installed into my Kubernetes cluster. If I look into my Kubernetes cluster, I do have a namespace here specifically for KubeCon. And if I look at the pods for my namespace, there are several pods that are currently running. And it is this example Nginx pod that we will be particularly interested in, where we're going to fetch the logs and certain content of that pod. So both plugins, the pre-flight plugin and the support bundle kubectl plugin, are open source. So is the whole Troubleshoot.sh framework. So how do I install those plugins? Well, they both are being available or made available through Crew, which makes that I can just make use of the kubectl Crew plugin to install my support bundle plugin. I already had these plugins installed previously. So as you can see, support bundle plugin, there is actually an upgrade available, and it is already installed. In order to upgrade all of this, I can run kubectl upgrade. As you can see, there are some warnings here about security. This is because Crew is not checking the security of these plugins, but I can actually check now if my support bundle plugin is having the right version, which is the case. I am on the latest version for the kubectl support bundle plugin. So what does it take to capture the logs of a particular pod in a Kubernetes cluster? I already previously wrote a support bundle specification. So let's have a look at this. So this is using, of course, the API version of Troubleshoot. And in this case, I have 3 different collectors specified. One is the default collector that will capture the cluster info. Second one will capture all the cluster resources that are running in my Kubernetes cluster. And the third one is the one that we are particularly interested in, because this will capture the logs of all the pods that match these selector criteria. I'm using the namespace, and of course, I'm also specifying some limits in terms of amount of logs to be captured. In order to run this, I can use the support bundle kubectl plugin, and then I will pass my YAML file, my specification, to the kubectl plugin. This will take some time because the different collectors are running sequentially in order to not make the problem even bigger if there is a problem with the Kubernetes cluster. So we will let this run for a little bit, and then we'll come back to this. Cool, it finished. So let's clear the screen and see what's part of the support bundle. Support bundles are stored as tarballs. So if you have a look, then you will see that there is a new tarball that was just created. We can also look at the contents of the tarball. And then you see there are quite a lot of different files available in here. There is one particular one that we're interested in, which is the logs of our application. So if we scroll back here, then you can see that there is one particular file that we're interested in, which is this log file in there, which is the log of the pod that we're looking for. If we extract our support bundle, then we can also have a look at the contents, and we can also capture what is in our particular log output of our Nginx container. As a next step, what we want to do is look for specific entries that are in the log output. As you can see, there is here a message ready for startup. So let's go back and let's improve our support bundle specification a little bit. And I already created a second support bundle that sits in here. And in this case, we still use the same collectors, but we add one particular analyzer that is going to look for the Nginx log output, and it's going to look for a specific message in that log output. And this is matched using a regex matcher. So if this appears inside the log output, our analyzer will tell the end user that Nginx is running. If this does not appear in there, then we're going to assume that Nginx has some issues. We can run this using the same support bundle, kubectl plugin. And we will let this run for a little bit. Great. Our support bundle is now finished. And as you can see, we have a different output. You can see that our Nginx is running. This is the message that we get back. And of course, we can save this support bundle, and then we can exit the output in there. So this gives already a more advanced representation of what you can do with troubleshoot.sh and support bundles. Next, let's do a little bit more of an advanced use case. Capturing the logs of a pod is one thing. How about if we want to exec into a pod? Because maybe you want to dump certain content from the pod and capture that as part of the support bundle. So there is here, let's maybe first clear the screen. There is here third version that I already prepared. And in this case, we are adding an additional collector, which next to the logs collector, we're also adding an exec collector. We're using the same selector. So we're going to exec into the pod that matches this selector. And we're executing a very simple command in this case. We're just capturing the content of a specific file in there. Obviously, in a production installation of an application, there might be more sophisticated commands that you want to run into those pods. If you wanted to run this, it will be the same command. That we can run. And again, we're going to let this run for a little bit. And then as a next step, we will add an additional analyzer. Great. So we get the output again that our Nginx is running. We can save this particular support bundle. And if we have a look now at the different tar files that are available, you can see that we already have 3 different support bundles that were created. We are most particularly interested in the last one that was created in here. Let's clear the screen. Let's extract this particular tarball. And then we can go into the extracted folder. And let's see what is in there. If you look into the support bundle, then you can see there is an Nginx content folder. And if we go all the way into that directory, you can see the namespace, the name of the pod also in there. And part of that is the standard output. That's the output of our cat command of the HTML file. As we didn't name the output file of our collector, we actually have to rename this one in order to see the contents. And now you can see what is in our HTML file that is being rendered by Nginx. One thing that you see here is some hidden text that is being exposed, and it is this hidden text that we will look for using our analyzer. So let's move on to the next step. So let's add an analyzer to our support bundle that looks for patterns like passwords, API tokens that are potentially in files that are part of our content. I already created a new support bundle in this case. So let's see what's in there. I still have the same collectors. One collector that collects the logs, one collector that execs into my pod. I still have my first text analyzer that looks if Nginx is up and running. But I also added an additional text analyzer that looks for my Nginx content, and it uses a regular expression to see if there are basically strings in there with ASCII characters between 20 and 60 characters. So yes, I'm a lazy person. There are much better regexes that can look for passwords or API tokens. But if this regex appears, if this matches, then we go into the when true case, which is going to fail, which means that we're going to send the message that there is a security breach. If this regex does not match, then we are sure that there are no passwords in the output in there. So again, we can run or create a support bundle using our new specification. Great. We have the output of our two analyzers. You can see Nginx is running. But as you also see, our second analyzer is failing because it detected passwords in our content file. As a next step, let's improve these messages here a little bit and give the end user a little bit more information how they potentially could resolve this. So one thing you can do is you can also add links to the output of your analyzers. This is exactly what I did here. For each outcome of my analyzer, I added a URI link that is going to help potentially the end user to fix the problem. Similar to the previous runs, I can use the support bundle CLI, a support bundle kubectl plugin to generate a new support bundle that will generate all this. Great. If you now look at our failed analyzer, you can see that it is failing. It has found the security breach. And it added also the link to go to troubleshoot.sh to get more information. As a conclusion, this means that if you are delivering applications that can be installed in a Kubernetes cluster, there is nothing that is limiting you also to provide your customers and users with support bundle specs that they can use to troubleshoot your application or framework in case something goes wrong. One thing that you might have noticed is that our support bundles contain a lot more than just the log files of our pods. If we have a look at the latest tar file that was created in here, which is basically this one, then you can see there's a lot of JSON output in here. Those are all the cluster resources. So behind the scenes, we try to fetch all the cluster resources in there and run the corresponding describes on there. Now, as JSON output is not very user-friendly, we created another command line tool called kubectl that you can point to a support bundle tarball, and then you can use your regular kubectl commands to interact with it. I already have kubectl installed, so let's clear the screen, and let's use kubectl to start being able to interact with all our Kubernetes resources that are in the support bundle. If we use kubectl, we can serve it and we can point it to our latest support bundle. That's the support bundle location. Once that is done, we get a kubeconfig that is being generated that is local. So let's split our terminal here and let's run this export of the kubeconfig. This means from now on, if we use our regular kubectl commands, we will be interacting with that support bundle. So from here, I can actually run get namespaces, and as you can see, kubectl is serving all of those requests, and you can see all the namespaces that are in my Kubernetes cluster. If I want to get the paths of my demo namespace, here you can see all my pods that are running in there. If I want to run a describe on one of those pods, then you can get all the describe information. So that makes that even if you do not have access to the Kubernetes cluster that your customer is using or that a colleague is using, you can still ask them to generate a support bundle, use kubectl to point to that support bundle, and use your regular kubectl commands to troubleshoot that cluster. Thank you very much for attending this session. If you have any questions, feel free to contact me through email, Twitter, or check out my GitHub. I also listed some of the links. Troubleshoot is open source and can be found on the replicated GitHub organization. The same is applicable for kubectl. And of course, you can always come by our booth at KubeCon. Thank you.